Okay, we have reached question 4. So for question 4, it is your standard vector diagram drawing. You see got angle, got forces. You should know that it is a question regarding forces. So the first thing you see is that you see that they give you in mass. So mass is not a force. So meaning that you need to turn this into a force, which is called weight. So to change mass to weight, you use W equals to mg. So it will be 130 times 10 if you are on Earth. So you will know that this is your 1300 Newton. Okay, then they are telling you that blah 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 blah. There are two cable there, and the cable is such that it is 25 degree, and then the force is called tension. So creative. Okay, part A, like I said, the 2020 paper, we try to give chance lah. As long as you study, we'll give you mark. Okay, so we always check on whether you memorize definition. Not sure if 2021 we will still want to do that. Okay, so anyway, for part A, this is how you you explain what is gravitational force. Like I said, the chapter mass, weight, density is self-study. This definition is inside. How to calculate weight? So it is a very straightforward question. We give it to you. This is how. For part C, it is slightly harder. Now you are actually being asked to use a scale diagram to actually find the tensional force. Okay, and they are telling you that the object here is actually stationary. So for a stationary object, you should know that the forces will be balanced, and in a vector diagram like that, balanced force simply means that it will form into a closed triangle, right? Balanced forces will basically form closed triangle. So if you forgot what is closed triangle, it means that maybe it will look something like that. The weight will be pointing down, and then after that you will have, maybe I call this T1, T2. You will have T2 over here, T1 over here, and then finally the third force will actually come back to where you start. So just now, before I do all this, I start from here. So a closed triangle meaning that it will end at the same point as well. Okay, so that is what it means by closed triangle. So now that this is that, I will show you how it starts. So mark out a point, any point, and then draw the crosshair. Actually, this is not called the crosshair. It is called a bearing. So this is my start. So label it. Then you should draw your weight, right? So you have your weight. For this, my iPad, it is not scale. But for you, your weight is about 1003. So maybe you can do a scale that is 1 cm is to maybe 1000 Newton. Okay. Oh, maybe this is too much. Maybe 1 cm is to 100 Newton. Okay, so you draw this line, and then once you are done drawing, right, you should always end with a bearing as well. I will tell you why. So now that you draw your bearing, right, you know that your next force, the T1 force, should be around here. You also know that your T2 force should be around here, right? So you need to have this kind of idea in your mind. But in order to draw this, you need to know this angle, correct or not, to draw it to scale. So you go back to this and you ask yourself, how do I get this angle? So from here you can see already quite clearly it is your alternate angle here, right? Correct. So you know that from here you need to just measure. So for me, I don't have a ruler. I will just measure 25 degree. Once I do that, I will just sketch out, use a ruler, sketch. Okay, because for T1, right, I do not know its magnitude, meaning that I do not know where it will end. But I know that the third force, the T2, will actually bring me back to the start point. So I know that I'm going to draw a line here, but I need to know this angle, right? So because of that, I will go back to here, and I see that, Isn't this my T2? 25 degree, right? From the horizontal. So this bearing over here allows me to quickly see which angle should I measure. So after I measure, maybe here I will measure 25. I will just dot the line out and I see that, oh, they actually intersect here. What does this mean? This means that my my T1 will be until here, and then I will have my T2 until here, and you should see that all my arrows on this closed triangle are single arrow. Because why? There is no net force. If there is no net force, no double arrow. Okay, so at this point I do not have the exact answer. I think I will text you separately on WhatsApp.